Hi guys, this is Prashun again. Today we will discuss about the one of the very important concept of matrices, that is how to find out the determinant, cofactor and adjoint of matrices. Basically these three terms, determinant, cofactor and adjoint, you will get whenever you will solve any problem. They may in the questions it may ask you what is the determinant of a matrix, what is the adjoint of a matrix. Generally no one asks about the cofactor, because cofactor we have to deduce the cofactor to find out the adjoint of a matrix. But anyway, these are the common term associated with a matrix. Like in the if you see the other chapters of algebra, then there are few terminologies. Like in case of log, someone is asking you to find out the log something to the base log 10 to the base log e, or change of base. These are the different chapters. So similarly here in matrices, determinant, cofactor, adjoint, these types of terminology are very common, and we have to find out all for either a 2 cross 2 matrix or a 3 cross 3 matrix. So first we have to know what are those, like what is the definition of determinant, definition of a cofactor, definition of the adjoint, and we have to find out how to find out those for a 2 cross 2 matrix and for a 3 cross 3 matrix. So this tutorial is about that. For just for your information, to find out the inverse of a matrix, we have to find out all. Like we have to find out determinant of a matrix, we have to find out cofactor of a matrix, and we have to find out adjoint of a matrix too. So in my there is a tutorial of mine which is related to inverse of a matrix, but in the inverse of a matrix I did not discuss about how to find out of determinant, how to find out cofactor, how to find out adjoint. So the theory portions of that comprised of this particular tutorial. Okay, so thanks. Let's proceed now. Things. First one is determinant of a matrix. In algebra, the determinant is a characteristic number associated with a square matrix. Please note the term square matrix. We can find out determinant of a square matrix. Determinant is a real number associated with every square matrix. Determinant of a square matrix A is denoted by different expressions. One is det, small det, then A. Another one is det, small det, then in the bracket, first bracket A, or sometimes mod of A. These are the three ways in which we generally write about the determinant of a matrix. What is the definition? A square matrix can be associated with a real number called its determinant. The determinant provides information when the matrix is that of the coefficient of a system of linear equations. The determinant of a matrix A is denoted as det, first bracket A, det only A, and or modulus of A. Let's see what are the different sign system for expansion of determinant. Like for a second order matrix, generally there are, for a second order you can see this is a second order matrix. So generally the signs are, first term is plus, second term is minus, a11 is plus, a12 is minus, a21 is minus, a22 is plus. And for a third order matrix, it is plus minus plus, then minus plus minus, then plus minus plus again. So these two things we have to just remember. First one is very easy, plus minus, then the reverse minus and plus. And for the third order, it is something like plus minus plus, then it is in the reverse order, and then again in the first order. Plus minus plus, minus plus minus, and plus minus plus. You can see that none of the two adjacent terms are of same sign. So that is one thing for remember. Okay, how to find out a determinant of a given, the formulas to find out the determinant for a 2 cross 2 matrix. How? Consider two homogeneous equations determinant formula. One is a1x plus b1y equal to 0. That is one equations comprised of x and y, and the second equation is a2x b2y equal to 0. From here I can find out the value of x and y, because there are two equations comprising of x and y. So multiplying 1 by b2 and 2 by b1 and subtracting, we can get b2a1x plus b1 b2y equal to 0. That is the first equation. and the second equation becomes b1 a2x plus b1 b2y equal to 0. Now if I subtract this second from the first, so b2a1x minus b1a2x, because the coefficient of y for the equation, first equation and second equation negate each other. So my equations becomes b2a1x minus b1a2x equal to 0. So dividing x from the above equation, we get b2a1 minus b1a2 equal to 0. Basically this is the formula for my determinant of a second order matrix. We write it as b2a1 minus b1a2 equal to 0 by a second order matrix with the term a1 b1 a2 and b2. So this is known as the determinant of order 2, and it is b2a1 minus b1 a2. So you have to remember this thing. Basically it is something like that, this into this minus this into this, that's it. So for a second order matrix, finding out determinant is very easy. We have to do this into this minus this into this. Okay, now we will find out the determinant of a 3x3 matrix. So here also we will consider 3 homogeneous equations with determinant formula, and there will be 3 variables. So one is a1x plus b1y plus c1z equal to 0. Second one is a2x plus b2y plus c2z equal to 0. Third one is a3x plus b3y plus c3z equal to 0. So it is represented in this way, like a 3x3 matrix with all the coefficient like a1 b1 c1, a2 b2 c2, and a3 b3 and c3. Because we are not reducing like 2x2 matrix, because that is a too much. So just for your representation, it is represented something like that: a1 b1 c1, a2 b2 c2, and a3 b3 and c3. So now let us find out one small example for how to find out determinant of matrix for a 2x2 matrix. My determinant is, find out the determinant of cos a sin a minus sin a into cos a equal to 1. You have to prove basically. So what we are doing, we are taking LHS. So LHS means my cos a sin a minus of sin a cos a. Now here, as per the determinant definition, we have seen it is something like that: this into this minus this into this. So cos a into cos a becomes cos a into cos a minus of minus sin a into sin a into minus sin a. So it becomes cos square a and minus of sin square a minus minus plus, so plus sin square a equal to cos square a plus sin square a equal to 1. So it is proved. This is very simple. So determinant, it is really very simple. In subsequent classes or in any problems and solution, we will do the third order determinant also. Even in the when we will find out the inverse of matrix, at that time also we will find out the determinant. Next one is minors and cofactors of determinant. Okay, so first we have to know what is minor. The minor of any constituent of a determinant is the determinant obtained by omitting the row and column in which that constituent occurs. What does this mean? That I will see with an example. Let's say it is a 3x3 matrix and there are 9 terms, obviously: a1 b1 c1, a2 b2 c2, and a3 b3 c3. The minor of a1 is b2 c2 b3 c3. Why? Because in my definition it is saying the minor of any constituent of a determinant, means any element of a determinant, is the determinant, that will be also a second determinant, obtained by omitting the row and column in which the element occurs. Like let's say if I have to find out the minor of a1, then I will omit the row of a1. So this is the row of a1 and I have to omit the column of a1. So this is the column of a1. So my resultant matrix becomes, the residual is b2 c2 and b3 c3. So this is the minor of a1. Now you can ask me, sir, what is the minor of b1? So you will do very easy. So if we have to find out the minor of B1, then we will omit the row of B1, that is this one, and we will omit the column of B1, that is this one. So what is the residual? Residual is A2, A3 and C2, C3. So A2, A3, C2, C3, that is my cofactor, sorry, minor of B1. So minor of B1 is A2, C2, A3, C3. So in similar way, we can find out minor of any element within a determinant, okay, or within a matrix generally. Now we have to find out what is the cofactor. So minor concept is clear. For find out minor, what we have to do, we have to omit that particular elements, row and column, and the residual things will be the minor. Now what is a cofactor? The cofactor of any constituent of a determinant is its minor with proper sign, either plus or minus. The cofactor of a constituent in the ith row and jth column is minus 1 whole to the power I plus j into minor of the constituent. So if we have to find out the cofactor, what we need to do? First we need to find out the minor. That is very easy, already we have found out. And before that we have to put either minus sign or plus sign based upon a formula. That is also very easy. Minus 1 whole to the power I plus j, where I is the row and j is the column of that particular element. Like my I and j we have discussed many times in different matrix situations. So let's take an example, then it will be clear. Let's say there is a matrix A with 3 cross 3 matrix A1 B1 C1 A2 B2 C2 and A3 B3 C3. Here the cofactor of A1 is A1 means first row and first column, okay. So I means 1 and j means 1. So minus 1 whole to the power I plus j. I plus j means 1 plus 1 and B2 C2 B3 C3, because minor of A1 is B2 C2 and B3 C3, because I am omitting the row of A1 and I am omitting the column of A1. So the constituent is B2 C2 B3 C3. I hope this is now clear. What is minor, what is cofactor? So cofactor is basically a minor with a proper sign. Now we have to find out another concept, that is adjoint of a matrix, okay. This will come from the minor concept. The adjoint of a square matrix A, that is Aij, is represented as transpose of the matrix capital Aij, where capital Aij is the cofactor of the element Aij. Transpose of a matrix is obtained by interchanging rows and columns. Cofactor of each element is determinant value of matrix obtained by removing the row and column which contains the particular element. So adjoint of A is denoted by ADJ, then A. We will see what they are trying to say. Let A be any n cross n matrix. N cross n we are writing because we are taking this as a square matrix. Thus, if A equal to A11, A12, like common matrix expression, then adjugate of A means transpose of the matrix, cofactor matrix basically. So A11, A12, A1n, A21, A22, these things we have to find out, that is the cofactor matrix. So transpose of the cofactor matrix is the adjugant of A, or we can write it as a A11, then A1, basically that will come as my column. So in this way we will do. So find out the adjoint of a 2 cross 2 matrix. Let us find the adjoint for the matrix 5, 7, 4, 3. So what is my rule? Let us take A equal to 5, 7, 4, 3. Step 1. Find out the cofactor of the matrix, right? So what is the cofactor? That is A11. So cofactor of 5 is, I will omit the row of 5 and column of 5, so it is 3. I am just writing 3. Basically 3 is the minor, Now to find out the cofactor, we have to find out with the proper sign. So that sign is -1 whole to the power I plus j. 5 means I1 and j1 because it is the first column, first row. So -1 whole to the power 1 plus 1, that is -1 square, that is 1. So 1 into 3 becomes 3. Next one is A12, find out the cofactor of 7. So I will remove 7's row and 7 column, so it is 4. So I am just writing 4 over here, and the sign becomes -1 whole to the power I plus j. So I means 1 because 7 means first row, second column, right? So 1 plus 2, that is -1 whole to the power 3, that becomes another minus, so minus of 4. So in this way I am finding all the cofactors. Cofactors of 5, cofactor of 7, cofactor of 4 and cofactor of 3. Now it becomes 3 minus 4 minus 7 and 4. Okay. Now the cofactor matrix of A is 3 minus 4 minus 7 and 4. So the adjoint will be the transpose of this. Adjugate A equal to transpose of cofactor matrix. So what will it will be? 3 minus 4, 7 minus 7, 4 transpose. Transpose means the rows and columns will be interchanged. So 3 and this minus 4 will become a column, and minus 7 will become a row, first row, second column, and this 4 will come as 4. So this is my adjugate of A or adjoint of A. It is very simple for a 2 cross 2 matrix. Hope this is clear. Let's find out the adjoint of a 3 cross 3 matrix. Okay, it is not very tough also. Let us find the adjoint for the matrix 1 minus 1 0, 2 5 minus 2, 3 2 1. How to find it out? So let's take A equal to this particular matrix. Step 1, we have to find out the minor or cofactor. So A11, that is cofactor of 1. So A11 means this one. So I am just removing this particular row and this particular column. So my remaining is 5 minus 2 and 2 1. So 5, this is a 2 cross 2 matrix. So it will be 5 into 1, that is 5, minus 2 into minus 2, that is minus 4, and with minus sign, that is plus. So 5 plus 4 equal to 9. So 9 is my determinant of this particular portion, that is the cofactor of 1. And before that I have to put the sign. The sign is -1 whole to the power I plus j. So 1 means I1 and j1. So -1 whole to the power 1 plus 1 into, and the remaining term is 9. So let's see, let's take a random example like A21, that is the cofactor of 2. A21 means this one. So I have to remove this particular row and this particular column. So my remaining is -1 0 and 2 1. So if I have to find it out, -1 into 1 minus 1, minus 2 into 0, so minus 2. So -1 into -2, sorry, 2 into 0, 2 into 0 means 0, so -1 basically. So A21, that is the cofactor of 2, equal to -1 minus 0, that is -1. But I have to find out the sign also. The sign is -1 whole to the power I plus j. A21 means this one. So it is basically second row, first column, that is I equal to 2 and j equal to 1. So I am putting -1 whole to the power 2 plus 1, that is -1 whole cubed. -1 whole cube means -1. So the entire things becomes minus of -1, that is equal to 1. So I have found out all the cofactor matrix now. So my cofactor matrix is 9 minus 8 minus 11, 1 1 minus 5, 2 2 7. So now I have to, there is step 2. The transpose of the cofactor matrix is basically your adjugate. So transpose means all the rows will become columns. So 9 minus 8 minus 11, this one will be written like this is a row, so it will be written in a column. 9 minus 8 minus 11, then 1 1 minus 5, 2 2 7. So my adjoint is done. So it is also very simple, it is not very tough. You have seen, we have gone through step by step approach. Fine. So these are all about the minors, cofactor and adjoint. This is needed for to find out the inverse of a matrix, or maybe in the examination they sometimes ask this types of things to find out individually. So this is the concept. Hope this video will help you. If you like this video, please like on the YouTube or subscribe me so that this video can be reached to wider audience. Thanks once again for watching the video. Have a good day.